Welcome to the Crazy Wisdom podcast. I've got Tyler Cloutier here, and he is the founder at Clockwork Labs. Welcome to the show.
Thank you so much. Thank you for having me.
So I reached out because of the name SpaceTimeDB,
Yep.
and there's Clockwork Labs, and then there's SpaceTimeDB. So how did you come up with that name for?
Yeah, it's an interesting question. Well, first of all, I just like I think Einstein's theory of space-time is really one of the defining theories of modern science. So I think it's a very interesting theory overall. But we were developing a database which stores data, but then also has time travel capability. So it can go back in time, and you can look at what the state was previous in time. So it just seemed to make a lot of sense. And I just always liked the theory, so I decided to go after that.
Very cool. So what does that mean? You can go back in time, like it picks up everything. My friend, I'll explain more. So the way I found out about your product is basically a friend of mine is using it. He probably found out about it through AI, and he's doing crazy 3D web GPU and 3JS type of stuff. And so, what does that mean that you can go back? You can go back at any time, and there's sort of full reproducibility.
It does mean. I guess let me give you just a quick background on SpaceTimeDB overall. So SpaceTimeDB is a database system, general purpose relational database system, so not specific to any particular application. And the interesting thing about it is that you take your application logic, you compile it into a WebAssembly module or a JavaScript bundle, as the case may be, and you upload that to run directly inside of the database. And we're able to provide very high performance because of that. But also the entire logic of your whole server backend is running inside of a database. And when I say that we can go back in time, what I'm saying is we're actually storing every operation and every change you make to your data persistently, indefinitely. I mean, you can choose to delete it, but we store it indefinitely, and you could actually set the state of your application back to an earlier point in time.
Cool. So how does it interact with Docker, if at all?
It's unrelated to Docker except that you could make the claim, like you can run it in Docker, that's for one.
Oh, interesting.
But you could also make the claim that you can, it's not Unix, but you could replace it for similar purposes to what Docker and Kubernetes provide. So it provides a sort of it's the real secret. It's coming out early in this conversation is that SpaceTimeDB is not really a database. It's more of an operating system.
Oh,
because
cool.
it's running your program and it's managing your data. It's not a Unix operating system. We don't have a file system. We have tables instead, but it's running your code. So you're running into sort of a sandboxed environment in that regard.
Okay, that's really cool because I just listened to, or didn't just listen to, it was a couple months ago. I listened to Satya Nadella on the Irish Guy from Stripes podcast, and a friend of mine sent it to me because we've talked a lot. My friend and I had talked about a lot about Bill Gates trying to build a file system into a relational database, and he kept on like bringing Microsoft to the wrong direction because he was trying to combine both of those things.
Sure.
And so, but you don't have a file system. You have a bunch of tables, and that tables, yeah, go for it.
Yeah. So if in Unix the abstraction is everything's a file, in SpaceTimeDB the abstraction is everything's a table.
Oh.
You could build a file system on top of tables in SpaceTimeDB. In fact, we may do that and support the what's called WASI, which is the WebAssembly System Interface, or I think it's syscall interface. I'm not sure exactly what it is, but essentially it allows you to it's a standard in WebAssembly that allows you to access Unix ABI functions by linking them into your host system. But in our case, we would do that, but we would back it all by tables if we wanted to do that. So that's just
cool.
an option that we can do in the future. But it would be a file system backed by tables, and it's fully atomic. So if you make a change to any tables, they either all happen or they don't happen at all. There's no in between, which is a property that is not true of most file systems.
So cool. All right. So this ties together a lot of things. I've done a lot of episodes on most sort of giantly is Urbit. And Urbit had a sort of a similar philosophy of essentially how do we replace Unix but replace it like in a networking protocol with peer-to-peer sort of server type of thing. So it feels
Sure.
very different than what you're talking about. But it goes back to that sort of Unix is this thing that we've all built on for a really long time and is a very old piece of technology. So you don't, and Linux is related to Unix. Is this a competitor to Linux?
I mean, functionally, it's not right now. I mean, what it is a database, but the ultimate vision for SpaceTimeDB is, I think, I don't know if it's a competitor. It's more of a, so we view it as a distributed operating system, and that basically means you have databases, and a database is kind of like a Unix process.
Cool.
And it accesses data, and you can spawn them, and you can spawn them across a cluster, so it scales horizontally. You can spawn more and more databases. It's similar in principle to like Erlang or Beam or Scala Akka, if you want to get a sense of what I'm talking about. It's an actor model system where each database is an actor, and it can send messages to other databases, and you can spin up a cluster, and you can spread these databases across the cluster. And so in that way, it's a distributed operating system in the way that Unix and Linux never was. Is it a competitor to Linux? I would say probably not. I would rather say it's sort of like an overlay operating system. It's an operating system that you're running on top of another operating system. So the thing that Linux provides that I think we would never compete with, or at least wouldn't for a very, very long time, is all the driver and device support, right? Like that's a huge part of what Linux actually does. What we want to do is provide a next layer up on top of that, which is an abstraction across many machines. So we're bringing the distributed aspect to Linux.
Oh, very cool. So, okay. And so, sorry, I'm going to ask a really random question. Cloudflare is, me and my dad have a show called Stewart Squared, and he talks about Cloudflare as the network operating system.
Sure.
And I've been trying to figure out what the hell that means. And then we did another podcast after he brought it up, and he was like, oh, I don't really know what that means. But because it's so abstract, right? Like an operating system on my Mac, that's really not abstract. It's like there, it turns on, and all of a sudden I have an operating system to deal with all these different things. But then there's like a network with the Cloudflare, and Cloudflare is the network operating system. Is that right? Do you agree with the Cloudflare is a network operating system? And where can I put SpaceTimeDB in that?
I'm not sure I know enough about exactly the different services that Cloudflare provides to say whether it is or is not. But Cloudflare has a thing called durable objects, which is functionally similar in concept to. It's not a relational database. It doesn't have those kind of properties, but the idea is that, and it also has like ephemeral in-memory state that you need to keep in sync with the durable stuff. But it is similar. It's sort of like, hey, we have this process. I have a durable object in the case of Cloudflare, and maybe I can send messages between durable objects. And it's the same kind of idea.
Cool.
I would say.
Okay. So, and I'm starting to get a much better picture. And so let me explain my vibe coding stack, and let me try to fit in where I can use SpaceTimeDB. So well, no, I mean, because I'm now obsessed with operating systems. I think the large language model itself is an operating system, but it's an operating system based on thought. And so I think we had a personal computer revolution where each of us got our own personal computer because of Apple, and Apple kind of integrated with Linux through the acquisition of Next. And so that kind of created this sort of like new operating system that's Mac based, but related to Linux. And now we have LLMs, and LLMs feel like they're an operating system, but only if you control the harness. And so right now I'm trying to figure out how to control the harness basically. And this is within the past week, because I've been traumatized. I'm just joking, but I've been traumatized by this sort of like thing that happened with Claude, where basically I was given these magical powers, and then they very rudely took them away. And so I'm now like, okay, well, I need to figure out this operating system, but it's in a totally different, like it's on the language side. And me as a humanities linguist type of person, like I really like that side. But you're like operating system here related to a database, but it's not a database, and you're doing it. So how can I use that in my coding journeys, basically? How can I use SpaceTimeDB?
Yeah, I mean, just to be clear, SpaceTimeDB is a fully relational database. It just turns out that databases and operating systems, databases are operating systems minus the code. So we're just putting the code in the database, and there you go. In a way. But if you're wondering how would you use this in a traditional software stack, that is very clear.
Oh,
It would replace, let's say, Postgres, and it would replace,
cool.
let's say, Node.js. So
Okay.
those two things are being merged into one system,
Whoa,
and you just
cool.
don't have to care about deploying them separately.
So Node.js and Postgres. And so my mentor who teaches me about all the vibe coding stuff, he's like a senior software engineer who's just like been doing all this stuff for a really long time. He kept on making fun of me whenever the AI would tell me to go do Postgres. He would like, why don't you do SQLite? And then you get the SQLite in your thing, and you just you can put it in your browser, you can put it on your phone. And so I get that, but I was just like, there's so many details I've been trying to pay attention to. I just never did it. So I'm going to try SQLite, but most of my things are built off of Postgres and also Node.js. I think that's the combination that AI really likes to give, basically, is Node.js and Postgres. And so what does that mean to combine them? Because Node.js is like it's like a full JavaScript where you have the database. Yeah, go for it. What?
So Node.js doesn't have the database. So Node.js is a web server. Well, it's an execution environment for JavaScript code. I guess how familiar are you with the history of Node.js?
Not very familiar. I know there is JavaScript, and I know the Chrome browser is JavaScript, and then that's where it
Okay, so let me see if I can break this down. So Chrome is a web browser developed by Google. Web browsers need to execute JavaScript code. So what does that mean? It means they take the JavaScript string, and then they have an interpreter, and they look at all the commands, and they carry out those commands one by one on behalf of the browser. Sort of the browser does this. It executes the code. So you could write a program that says like print to the command line, and it would interpret your code and it would execute that. Interpreting is quite slow.
Okay. Yeah.
Or it can be.
Yeah.
This is a kind of a long story, but yeah. I'll just kind of summarize. Interpreting is slow. So what the Chrome browser does internally is something called JIT compiling, which stands for just-in-time compiling. And what that basically means is the interpreter looks at your code, the JavaScript code. It maybe executes it a few times and then says like, hey, I'm just doing the same thing over and over again. Why don't I compile a couple of these, like this function or something, into machine code? So literally code that will be executed on the CPU directly. I will write that into my program memory, and then I'll tell the CPU to jump into that program and begin executing those instructions.
Wow.
And so that is what interpreting is. And then there's a whole bunch of security features to make sure that you're not, jumping into malicious code that's going to do crazy things. So it has to be sandboxed inside of the browser. So you can't get out of the browser. In fact, you can't get out of the Chrome tab. And there's a few ways they do this. And the system that they used to run this JavaScript is a subset of the Chrome browser. It's just a system that they wrote called V8. And V8 is a JavaScript engine, meaning it takes in, the input is a string of JavaScript, and the output is it runs your code.
Cool. Okay. So wait. Does that make the Chrome like from what I got you said is that the Chrome browser is uniquely tied into my CPU and my GPU due to this interpretation layer, and it's almost like a virtual machine?
It is a virtual machine. It's kind of like it's in some sense it's an operating system as well. In fact, there's Chrome OS, which is
of course, right? Interesting. Yeah. Okay.
So it's using your browser is taking programs and it's running it and it's providing like file systems and you can access different things inside of the browser. But it's a different. It's not a Unix operating system. It's a browser situation.
It's so crazy. The web stack is so interesting because there's so many operating systems at so many different layers.
In a sense, yes.
And so, okay, so I didn't mean to interrupt you. So the Chrome browser is doing this JIT compiling. The interpreter is quite slow. And how does that relate to Node.js?
Yeah, so they made this thing called V8, which does this very, very fast JIT compiling of JavaScript and executes it so that the speed is like comparable to a compiled language, a pre-compiled, statically compiled language. I can't remember his name, but basically an open source developer said like, hey, this is really cool what these people built for Chrome. A lot of people know JavaScript because they have to know it, but I'm writing like Apache PHP or something on the server, and then I'm writing JavaScript in the browser, and I would like it to just write in one single language. So I will extract V8 from Chrome. Actually, Google did this for him, but extract it from Chrome.
Whoa.
I will run the JavaScript engine on the server, and I will provide all of the Unix APIs via JavaScript so that it can access the file system and it can do all of this stuff. And I will also build in an HTTP web server, which is a program that runs that listens on a socket and then responds to HTTP requests. And I will provide this environment so that I can execute JavaScript code on the server. That is what Node.js is.
Okay, great. And so why does AI constantly tell me to use Postgres and Node.js?
It is somewhat of an industry standard.
Okay, got it.
So it's just they're both open source and they both become relatively popular. And so there's a lot of code out there written in these different things.
Cool.
And so it will by default recommend that as just like, well, this is a pretty standard stack.
Now, what type of applications are you guys running the most? If you can talk about it, what type of applications? Why did my friend find out about this for WebGPU and 3JS?
So we originally developed SpaceTimeDB not as its own product, but as the backend for our game, which is an MMORPG called Bitcraft Online.
Yes, I love it.
And Bitcraft Online is a single world MMORPG where all players come together in the same physical world, and then they rebuild civilization from the ground up. So there's a lot of persistence in it, and we needed a simple way for our game engineers to write the back end of our game and have all of the data be persistent by default, while not having to care about the distributed systems. And so we developed SpaceTimeDB for that purpose, and then we found it was much more widely useful than just within our company. So we made it available. And then at some point, we got a lot of game developers building games on top of it. And we thought, well, this is also useful for web, so let's bring it to web. And just about around in like February, we announced SpaceNG 2.0, which supports JavaScript. We actually use the V8 JavaScript engine, so same exact thing that Node uses. And we execute your program inside of the database in this case. So instead of it being on a Unix server, it's inside of SpaceTimeDB.
So you've abstracted something. What did you abstract?
Can you be more specific with your question?
That was just like a random question that just popped up into my head because it's like, so let me try to figure out. So programmers abstract things, they find these problems, and then they like abstract it, right? So you have a hardware, you have a machine, and then they have the assembly, and then they built the C, and C abstracted something from the assembly, right? Is that right?
Yes, it does. I mean, it has in a way. That's correct.
And so basically, you guys have done this thing that is like, I guess the question is why does it exist? Why did games require this? Because it's distributed, because a lot of people are doing it. It's probably really heavy on the graphics, right? GPU.
It's actually
browser.
It's not. Let me provide. I think I understand your question now.
Yeah.
So SpaceTimeDB, all MMO backends have been an exercise in some like custom code. So people are making these custom backend systems to do their game engine. What we said is we can kind of unify that all into a single system.
Cool.
Which is called which is a database that executes the code as well. So we can do everything that you need to do on the back end inside of one system. And so that's the abstraction we made. We said actually all MMOs, if you squint, are just databases.
Whoa.
On the back end, they just don't know it. And so we will abstract this into a sort of a higher level, and we will do this. Why do games specifically require this? And like, why have web apps gotten away without using it for a long time? The answer to that is that web servers are typically stateless. And a lot of people don't understand, well, why are they stateless? And what does it mean to be stateless? So it means in particular that you're not holding any state in memory, and each request doesn't hold any state across the request. So if you do a request, you get a response. It doesn't keep any state around. And perhaps I think a lot of people don't understand, well, why is that? Well, it's because you might want to have 20 web servers, and you need it so that it doesn't matter which one you go to. And in order for it to not matter which one you go to, there needs to be not any state left in one that's not in the other one. So like, let's say, for example, I stored your username not in the database, it's in the web server. Well, if I go to web server A, it has your username, but if I go to web server B, it doesn't have your username. So I have a problem. And so typically they're stateless, and all of the state lives in the database. But web servers are able to get away with this because they typically don't need to be super real time. So they're fine to delegate everything to the database. Just go to the database and get the data, and I will pay the network round trip time every time to go get that data.
And all between all these just thousands, in a large company that has thousands of databases or thousands of servers, basically.
They may, yeah. It gets very complicated on the back end, but in a simple system, it's going to be web server, and its client connects to the web server, which connects to the database.
Yeah, okay.
And the web servers don't store state; they just ask the database for the state.
Got it. Interesting.
Games cannot afford to always delegate to the database, or they couldn't, because the database was far away and it was slow.
Yeah.
For complex reasons. So they store state in the game server.
Oh.
Okay. But that means that they can only have one game server per database, basically. And the database just sucks in the game server sucks in all of the state from the game server. The game server sucks in all the database state at startup, and then you just work inside of the database server and you periodically write back out to the database. And it's a very complex system that you actually have to do. And this is because things are real time, so you can't afford to go to this database every time. So you need to do it just in memory in the server. And what we said is, well, could we not just make the database faster? Or could we not, the same thing from a different angle is, could we not take the game server and turn it into more of a database? But it turns out that the same performance gains that you get from doing this for game servers also apply to web servers. And that is
that's how you ended up there. So basically it's also, and that's really interesting because now with the vibe coding stuff, it's really crazy. Which is I now have multiple servers. So I now have multiple servers that are part of my personal server network, which is really cool. And I love, well, I won't say that, but so I love having all these different servers. And so it starts to make me think about distributed systems. And you guys are like way over on the other side of the universe, like already have figured out how to do distributed systems for games and for a lot of other things. So your first applications that are using are games. What other types of applications would be useful, or are you guys serving that I can kind of fit my head around in order? Because there's other things I could say, like I am now. So now I've got my servers, I've got my whole podcast under my control, and I've built my own RSS feed, and I've built my own recording software, and I built my own clip making system. And so I've got all these things that are like that I'm ready to go, and I'll get the full invitation, scheduling, recording, post-production, publishing, and then website. And then once I have that website, then that'll be the only thing that's exposed to the internet. And that I want to turn that into a bit of a game, and sort of like a fun game. At first I was thinking large language model, like just like install a large language model and do the GDPR stuff, like have it be a fun game where you can like chat through the GDPR stuff. And it's like a wise wizard or something like that, who's like, make sure you give the consent and then you go through it. But then I was thinking, well, it would be cool to actually like have a real game, because I've been seeing all these other vibe coders just like completely go crazy with building real games, and so it feels like that there's the answer for one of them, is that I could use SpaceTimeDB inside of this game, but I don't know what that will look like yet.
That's right. So you could use SpaceTimeDB as the back end for your game, and it would be able to do everything from so I mentioned we built it for Bitcraft. Everything on the back end of Bitcraft runs through SpaceTimeDB. So all the player movements, the positions of the players, all the chat messages, all of like the trading and the items and the inventory, all of it. So in your case, if you had a multiplayer game, you would store the state of the game inside of the SpaceTimeDB, and then it does the real-time stuff for you. So you can make a query to the database, and then you can subscribe to that query. So it will give you the results of the query, and then it will hold the connection open. And anytime the results of that
Wow.
query changes, it will stream that down to your client.
Wow. And this enables it enables games. But how does that translate into other applications? Like, why would an application need that?
Well, many people, I don't know. It's kind of an accident of history, I feel, that more things aren't real time. The fact that you ever have to refresh a web page to see something update is
interesting.
ridiculous. So I think any situation where like, hey, I have a thing and it might change over time. Let's say you're building, or let's say you're building Discord, right? That's a web app.
Yeah, interesting.
Well, Discord has chat messages, and if you put a chat message in, you want to get that chat message immediately down to the client, right? Or you have an online status. Let's say you're building Facebook. You have an online status. You want to see if people are online. Well, that should update in real time. You shouldn't have to refresh your web page to see who's online. That's crazy. Let's say you have a banking application and somebody does a transaction. Well, it should just show up in your bank statement without you having to create a new bank PDF or statement PDF or anything like this, or refreshing the page or any of that. There's literally, I think the crazy thing is that we've made it so far without real time. Not that apps don't need real time.
This is what my dad is constantly going on about Facebook and what Facebook did in 2006, and that's why React exists, right? Is because of that state problem. That actually answers the.
React and SpaceTimeDB. So we support React, but on the back end, the functions that you write in the database are called reducers, and that is actually directly inspired by a thing called React Redux, which maybe you have heard about. I'm not sure, but it's a framework for managing your state in React. And you basically take the state of your application and you make a change to it, and you reduce that change. It's called reduction. I don't really know why. It's like a functional programming thing, but you reduce it. I guess I do know why. You have a state machine. So how does a state machine work? You have state, and then you have changes to that state, and you are folding the changes into the state. So you're saying like, I have all of the users in my application, and I'm going to add a new one, or I'm going to delete 4 of them, or I'm going to change their username. And so you make all of these changes incrementally, one after another, to the state. And we call that process reducing. So they're called reducers. So you are reducing your request into the current state of the application.
Got it. And so, the state thing is so interesting because it was about 2 or 3 years ago when ChatGPT came out. I immediately tried to get to code in Urbit to get it to code Hoon or Knock. It could not do it. Couldn't do anything else. And so the same friend who sent me SpaceTimeDB also sent me a course on React. Because I was like, okay, this isn't gonna code for me, right? I now have the tool to teach me how to code, but which I had previously not had, and that was the blocker. And now I have the cool tool to teach me how to code, but not to code itself. And so he sent me this React, thing because he's all working on 3JS, and now I'm understanding why that like the state thing was so important for his like online multiplayer game type of thing. Like that's really important for his 3JS and like designing these worlds because the state moves around, he's in 3D time and stuff.
In real time, yeah.
Yeah. And so I get that, and it was so hard to understand what state was when he sent me that, because it's like, why was everybody talking about state? And then my dad started talking about what Facebook did, and what Facebook did was allowed 1 billion people to all be on the system where state gets updated in real time, right? But you're right. Like, why does that not exist? Why is Facebook, Twitter, like the social media company? That makes sense, right?
MMOs have been around for a long time, right? What is Facebook if not a text and image-based MMO?
Interesting.
It's a way to think about it. But it is, and in fact, it actually shares architecturally the back end. It has similar requirements. Not exactly the same, but pretty similar. And so I always was thinking, why couldn't we unify the web world with kind of the game world and have one system do both? Wow. That's kind of where we came from. And the missing piece is the database. It
Mm.
needs to be able to do the web stuff. It needs to be able to do the real-time stuff. It needs to be able to do the game stuff.
Man, that's interesting. So why
Yeah.
didn't Facebook or all the other ones come up with their own database? They must have run into this,
They've
right?
come up with things that are so first of all, it's a very
Mm.
large company.
Mm.
It's a very crazy idea. Hard to get crazy ideas
Yeah,
through a large company, so
yeah,
something to consider.
yeah.
But Facebook has produced things that are quite innovative. I think React is one that, hey, we want to do things in real time. We want things to update in real time. Let's do React so that you make a change to your state and it just filters through and renders the new web page.
Yeah.
There's also things like GraphQL, which was created by Facebook, which is a way to take your server and query your server with a query language.
Oh,
Does
whoa.
that sound familiar? It sounds like they're turning your server into a database of a kind.
Oh, interesting.
And that is because the old way of doing it is you have like API endpoints. And so let's say I'm Facebook and I want to make
Yep.
Facebook. And so I have like, I want to get my profile. Well, I have to get like who my online users are, like my friends that are online, and to who my friends are. I need to know like my current profile information. I need to do all of these things. And then every page is slightly different. And I want to get a slightly different set of information. And so what you used to have to do is say like, okay, I'm opening the web page. First do a request to find out my user information.
Hmm.
And then once I found out my user information, I do another request to find out all my friends. And then if I want to find their friends, I need to do another request to find their friends, and so on. And you do these back and forths. And so
Yeah,
what
interesting.
Facebook decided to do is make a query language. So you could say, hey, I want my user and my friends and my friends' friends, and I want all of my information, all the invitations that I have, and I can do this in one query
Yeah,
and get all
interesting.
the results back
Yeah,
at
yeah,
once.
okay, got it.
And it is a reason it's called a query language. It's because it's a way to query data. And what is a system that queries data is if not a database.
So that's what a database is. I was going to ask you, what is a database? And it's a system for querying data.
That is one property of a database.
Okay.
Databases are kind of like in my opinion, it's sort of like the ultimate program.
Hmm.
In that it does well. It's an operating system. So let me explain.
Sure.
Let's go back to 1969. I think there were a lot of databases, and what the purpose of a database was before is, hey, I want to be able to store my data durably, like on disk, not in memory, and I want to be able to query or access it. And it wasn't necessarily querying, but it was like, I'm going to write a program. I'm going to walk over my data. I'm going to be able to ask questions about my data.
Hmm.
It's no more than a data structure, I suppose, back in the day. And
Interesting.
this gentleman by the name of Edgar F. Codd came up with the relational model of data, which is a way of declaring your data model, which is separate from the physical representation of how that data is stored. And so you can ask questions about the data without needing to know where exactly it is on disk or where it's stored. And he came up with SQL, structured query language, to do this, more or less. I'm abridging a lot of stuff,
Yeah,
but
yeah, yeah.
that's pretty much the situation. And this basically allows you to say, hey, I want to know, like, what are all, like, I want to aggregate this data, or I want to ask, where is this user? Or I want to get these different fields for this user, and so on, without needing to know or find out where it physically is on disk. So it's a way to abstract
Oh, interesting.
the
Got it.
location
Okay.
of data with the query that you want to make with it. And so it's a way of I guess specifying a set of data that you want to find out about. That is one property of databases. Another property is one that I'm mentioning, which is that it also stores things persistently to disk. Another property of databases is that it maintains certain what are called invariants. So if my user, I want to maintain the invariant that all the users in my database have unique usernames. So I never want to allow a duplicate username.
Hmm.
Right. That's
Yeah,
one
interesting.
property. Another property might be that I want to run a bunch of changes to the data in parallel, but I don't want to know. This is a more complex property, but basically, I want them to look as though I've run them serially. They will not interfere with each other. So it's not like I update your username and I update Bob's username. I have another query that's also updating Bob's username and they get all garbled. That's a problem.
Yeah. Okay.
That is another one. So these properties, you can put them together. They're an acronym, and these are the common ones. There are more than just this, but the common ones are ACID.
Yeah.
So it stands for atomic, consistent, isolated, and durable. Atomic means if you make a change, it all happens or it all doesn't happen. It can't half happen. For example, in our game, if I want to trade you an item, the first thing I do is I put the item in your inventory and then I delete it from my inventory.
Yeah.
If that only half happens,
Yeah.
so
Yeah.
I
Yeah.
only put it in your inventory but I don't delete it from mine, then we've duplicated the item.
Got it.
And that's a very bad problem in an MMO because now you have an item dupe bug. And so people can just copy gold or they can do whatever it is that they want. So the atomic property means that the database is going to ensure that either both things happen or neither thing happens. It's not possible that only one of the two things happens. The consistency property is, which is what the C in ACID stands for, is that your invariants always hold. The database will enforce them. So you cannot have usernames which you said were going to be unique but are not actually unique because there's a duplicate. The I in ACID stands for isolation, which means if you have multiple things happening at the same time, they're not going to interfere with each other.
Cool.
They're isolated. They run separately. And then durability is the D in ACID, and it means when you make a change, it's now durably persisted. So it will not, if you turn the computer off and on again, it will not go away. And durability is kind of a gradient. You can be more or less durable. You can put it in only in memory on the machine. You can put it on memory on multiple machines. You can put it on disk on multiple machines. You can put it on disk on multiple computers across the world. There's different levels of durability.
So that was really interesting. ACID, 2 or 3 years ago, ACID was the one. It's funny, it's named ACID, and it was created in 1969. That's so that was one of the ones that I was just like, I was trying to learn that 2 or 3 years ago to understand it. Now I get it much better, and it reminds me of the double entry bookkeeping.
Double entry bookkeeping, sure.
Yeah, a lot of people make the claim that crypto is like I don't know if this is the right one, but triple entry accounting or something like that because of a public ledger. But then oftentimes people criticize crypto for being like, oh, that's just like a dumb database. Like, why didn't you just put it in a database? And so, yeah, go for it.
Yeah. So SpaceTimeDB, how does it work? You take your program, you compile it to WebAssembly, you upload it to run inside the database. And then we enforce that it has atomic properties, consistent properties, isolated properties, and durability properties. It is essentially a smart contract system. It's the smart database. It's not the dumb database. It's sort of it's a smart contract system, but it does not have cryptocurrency and it does not have global distributed consensus.
Good. Oh, wait. So it doesn't have cryptocurrency. Great choice. The second one, what was the second one?
Global decentralized consensus. So what I mean by that, there's words, but basically global means across all computers in the world. Okay, so you're running into speed of light problems, space-time. Okay. If you want speed, you have to, so you need all of the computers to agree in the world, in the whole world, on a particular thing, which means you need to talk to all of them.
Yeah.
Because otherwise you can't do that. Decentralized, meaning they're not controlled by the same person. Consensus, meaning they all agree.
Yeah, interesting.
Global, decentralized consensus. And the problem with that is it's very expensive and it's very, very slow.
Yeah.
So we don't do that. We basically said like, hey, you said crypto is like a dumb database. What if we take the dumb out of that database, but we keep the smart parts and we keep the smart contracts in a way?
Yeah, interesting. The smart contract thing, that's probably a really bad name because the contract feels like a legal thing. And I think there is some sort of legal thing that can be done in crypto. But
yeah, they call it smart contracts. I think it's actually, I don't know.
Why?
I think I think it was maybe Vitalik Buterin, the Ethereum guy who coined the phrase. I'm not sure. I think it may have predated that, but he popularized it. And it's Why are they called that? It's because in Ethereum, once you create one, it can't be changed. So it's like indelible. It's on the blockchain, and that's the way it is, and it's not going to be changed.
Yeah.
In SpaceTimeDB, you can change them. Although in principle, we could make it so you couldn't change them. And then we're basically saying, hey, the contract is between you and Clockwork Labs, that we are not going to change the code that you originally put up there. So if you had a banking application and you publish that to SpaceTimeDB, we could make sure that you cannot change that, so you can't steal people's money. But you're trusting us.
Interesting. So it's I just ran into this idea of, because that's what Fireblocks does for the crypto industry. Fireblocks does something similar to what you were just talking about. I did a great interview with this company called Ika, which is trying to do that in a decentralized way. That's really interesting.
So this would be a centralized way. You're basically, instead of trusting nobody and trusting math, you're trusting us that we're not going to mess with the contracts. But we are certainly not incentivized to do that.
Yeah. Oh man. Okay. So now we got this database. It can create state, or it's a stateful database. Stateful distributed database.
Correct.
And that can, I think we might have to get out of the technical stuff, because I'm getting
Sure.
So like, oh man, let's go into history or physics, space-time, philosophy. History sounds like the most relevant, because we were talking about distributed ledgers, not even the double
entry bookkeeping.
Yeah, double entry bookkeeping. Where do we go? Because it's like, this is gonna, I mean, your app as well, but, and I guess that could be the question, is like, how does it fit into AI? How does the nation state, because the nation state is so wrapped up with the double entry bookkeeping, and you have the information age, you have finance, these Medici guys who figured out this thing that allowed, and it's very abstract. It's just like this strange conceptual thing that allowed them to figure out how to make things true, or account things. And then now we're at this place where there's so many tools like that, and like, where are we headed in terms of this? Like, what's going to happen to society, the nation state, like history, like where are we headed, particularly with AI, and like, how does AI wrap up into your vision of where space-time goes?
I'll start, I suppose, a little bit smaller than nation state, but the way that we view SpaceTimeDB is that it is a distributed operating system, and more than that, it should be how the cloud works. So if you look at how the cloud works today, it's a collection of all these services. You have like S3 and Kubernetes, and you're gluing them all together, and you have a DevOps team, and you maintain all this stuff. The way we view it is that the cloud should just be a set of computers that all run a single operating system, and then from the outside, it looks like one enormous computer. So you just say, hey, just like you say on your computer, like, run my program, I could say to the cloud, run my program. Just here, space-time publish, please run it. And take care of everything behind the scenes, the whole 9 yards, all the deployment and routing and networking and persistence, all of it, just take care of it for me. That's how we see the future of that. That is very useful for AI agents, because just as it's very complex for humans, it's also very complex for them. They write software. They're not the best at infrastructure, because you have to take into account all of the different services and how you're going to hook them all up, and the state is all shared between them, and all of this stuff. So if you could just say, hey, AI, why don't you deploy me a new application that does X, and it just says, sure, space-time publish, and then the code, and it all goes up and runs. We think that that's a very positive development for how software gets run. I think there's a lot of focus right now on the infrastructure that is required to build software. But I think you would agree with me that probably over the next 12 months, there's going to be more software written than has ever been written before.
So crazy.
I think you'd probably agree with that, right?
Yeah. No, there's going to be more servers bought. Everything about. It's so funny, because the narrative is that programmers are going to get out of jobs, but there's going to be so many problems created by.
Basically, what we're saying is that there's a lot of focus on the infrastructure to build the software, I think there's insufficient focus on the infrastructure that's going to be required to run the software that these things are creating.
Oh, interesting. Okay, got it. So now I can fit that into where I'm headed. Or
Yeah.
and it
And so
does.
we think that we are a perfect sort of target for LLMs to write software for.
Oh man. So does that make you guys what is the relationship between SpaceTimeDB and something like Replit or Vercel?
Yeah, good question. So they're building. Well, I can't say too much about this because we're talking with a few of the vibe coding platforms uh, because I think we can provide very strong infrastructure for them as they're building. And we've actually done some testing where we basically say, make an application with Postgres versus make it with SpaceTimeDB. And we see
Mm,
that like you use, it's 43% less tokens to get the same thing done. You spend
cool.
less time fixing bugs. It just gets more done quickly. And so it's like maybe it costs you $20 to build the app in Postgres in terms of tokens, and it costs you maybe $10
Mm.
in SpaceTimeDB to build the same app,
Mm.
same functionality, and it's easier to extend. So this is obviously very valuable for these sort of vibe coding platforms because their
Mm.
primary cost is tokens. Not to mention, then you have the performance cost of actually running the application. And so that's how we fit in there. Now we could build
Mm.
our own vibe coding platform on top of SpaceTimeDB.
Do you know Cloudflare did that?
Did that? What did they
Yeah,
do?
Cloudflare basically created their own lovable Replit Vercel. Basically, I'm not sure how used it is, but they built their own sort of like in that genre.
It seems I don't know. I'm torn about whether we should or should not because it's kind of like a little bit more. We don't have to do all that much. It's just say,
Mm.
hey, make a system that deploys things automatically to SpaceTimeDB. Um,
Man,
but
really
yeah,
excited about trying this out. So I think I've answered the question about where you guys fit in with Cloudflare. Well, actually, no, I have not figured that out because basically, so we've got a server, we got a computer, and I have my personal computer, and I build things locally to that. But then sometimes I deploy those things,
yeah,
and there's a question there of like, it feels like what you guys are doing is helping with that deployment layer at some point, but I want to kind of get through the whole thing that I was saying. Once it's on a server, then it's interacting with the internet in general, which is just a bunch of servers and clients all interacting with each other with physical data pipes. And then Cloudflare came in and created a DNS product that helped with that. And because that now there's like 30% of the traffic goes through Cloudflare, because they are doing it, and then they're becoming just I would say they're becoming a competitor to Google. Although that's a good question now because Google has this browser with Chrome that's like so fundamental to a lot of things. And that's like the internet, but then that's not all of computation because you also have intranets. And then you have things like Tailscale, which give anybody the ability to build their own intranet. And yeah, it's such a interesting. So then, where you guys fit in, it's almost like before the Cloudflare layer. You're at the deployment and database. That's what you guys do. Is you there? Do you guys give any advantages for deployment?
certainly because you publish it and we figure out where to put it on all the machines and we handle all that for you. So it's deployment, server, and database. We do all three of those things. We
Got
do
it.
not do the networking. Like for example, you could put Cloudflare's
Got it. Yeah.
DDoS protection in front of
Yep.
SpaceTimeDB. That would maybe make sense. In
That's
fact,
the
I
Wild
think we do
West.
that.
They're focused on the Wild West. You guys are not out at the Wild West, although you can interact with things at the Wild West. You're before
Sure.
that happens, basically.
That's right. Yeah.
Yeah.
I would say that's a reasonable way to put it.
Do you think the internet's going to die, or do you think the internet is dead because of AI?
No, I don't. I mean, I
Yeah.
think it's actually going to be greatly used a lot more. I mean,
Yeah.
these things need to communicate, and so the internet is how you do that in the modern age.
Is
Maybe
it-
the internet as it was
Yeah.
may not
The
live.
social aspect of the internet. Do you think that that's going away?
I think it's too valuable to too many people, so the people will find a way
There's going to be things will figured out, basically.
to make it continue. I mean, there will be a problem of bots, but people will be trying to solve that problem.
Yeah, the question is whether that itself is an existential question, or whether there's some law of the universe that can be handled in order to differentiate between bots and humans. Which is, I have not figured that one out. Do you have bots in your game? What was it? Bitgate?
Bitcraft is
Bitcraft.
the game. Are there bots? People have tried to bot the game. We try to detect them and ban them
Interesting.
because bots are not allowed. But yeah, I'm certain.
What do you think? What do you think is the proper balance in a game between bots and humans?
It's an
Depends
interesting
on the
question.
game.
Bots tend to. So games put sort of artificial progress or goals in your way. That's the whole point of them. Is they're fun. They're fun to go through to accomplish the goals, to go through the challenges.
Yeah.
Bots allow you to do that without doing it, right? It has something else do it on your behalf. So it kind of ruins the game for everybody else who's trying to play the game, because the progress is less valuable because somebody else has cheated their way through. And so I think it's tricky for games.
Well, so yeah, no, and I think this goes back to it depends, because you're talking about a multiplayer game, right? And so with humans all collaborating together to do things, basically. Whereas I was thinking about it from my old days of Red Alert 2, where I would be playing against a bot, basically. And so there's the adversarial nature of the bot, which depending on the game is really cool. Man, I want to. I think I want to start building games. Yeah, what do you think?
Well, I thought eventually I'd like to make a game called Against the Machine, where the whole world works together against a bot.
Yes,
that would be fun.
I mean, maybe that's it. Maybe that's the solution to the proof of human. No, well,
not really. You need some way. It's getting increasingly difficult to tell whether something, without looking at it in the flesh, is a bot or a human.
Yeah,
So I would say some kind of biometric system, or issuing everybody who's born when they're born
whoa, that's interesting.
Some kind of a
token or
basically a social security number, but actually secure instead of what it is.
Yeah, interesting. So oh man, that's going to be interesting. What do you think? I mean, that kind of goes into like Pokemon Go, because you said whether you've seen them in person, and then I think a lot about games, because that's what I want to do, which is like I want to start. Like the AI is coming, the robots are coming. I'm not very interested in fighting them. I think that's like a losing battle, both at the physical fighting them and also the ideological fighting them with the Luddite stuff and everything like that. I mean, if that's what people are doing, I think all more power to them. But I think it's just like a not a winning battle. And so I want to sort of create the conditions by which we can do events in person, in nature, and bring subtle and tasteful technology, but without the kind of doomer versus accelerationist type of thing where it's like, oh, they're all gonna kill us, or oh, they're so great, like let's turn them into a god type of thing. But like little, like nice, like maybe like what the Jetsons kind of did with the robots, like that type of thing where they're kind of funny and like helpful, but not gonna do all those things. And so I think a lot about like how could I create an in-person game, which has got me into the treasure hunts. I've started sending people on treasure hunts, both in person and now with my website. I'm going to basically create this treasure hunt type of thing, but that's all in the making still.
So if you wanted to track or like show people on a map where they are in real time as they move around, you could use like iOS GPS or something plus SpaceTimeDB to show the positions in real time. That's something that would be totally reasonable.
Oh, that brings ideas that I haven't had for like 15 years about maps. Oh, that's really good. Oh, interesting. That's going to take some thought. Okay. Well, yeah. Anything else? Any last sort of things you want to get out there?
I guess I would say, if you haven't started us on GitHub, give us a star. We're always looking for stars, and try out the platform. It's pretty much a joy, I would say, to interact with.
And so it's on SpaceTimeDB. Is AI sending you a lot more people? I mean, can you even track that?
Well, yes. I mean, you mean from the AI agents itself?
Yeah, because I'll explain I set the question up. So I found you because a friend of mine probably went on AI and he asked how
Sure.
to do something, and then SpaceTimeDB
It
comes
said
in.
like, yeah, it
I
should be it.
find a lot of podcast guests. That's probably how I found your Twitter, is that I
Right.
just asked the AI. Like, so I find a lot of podcast guests via AI. Can you, like, first, can you actually track that? Sounds like it would be really hard to track what I did, but yeah.
Usually the AI bots will tell your website if they are AI. So they will put in like a URL parameter, UTM, or if they produce a link, they'll say like ChatGPT is where they come
Oh,
from.
that's
So
interesting.
I mean, you can always delete that from the URL, but
Yeah,
by default they'll be there.
yeah,
So
yeah,
uh, if you ask ChatGPT to send you to a website, if you click the link, you'll see UTM
yeah.
underscore ChatGPT.
Okay, yeah, got it.
They
Interesting.
came from.
So you can track it if they haven't gone in and explicitly said that. And then what was the other question? Well, yeah, is it are you getting a lot of new clients via that? Yeah,
We are. I
yeah,
mean, I think that's how people are finding things these days. So
yeah,
it's a big component of that. So
yeah,
I mean, we also get people just from they see our YouTube content, they see our Twitter content, and they.
yeah. There's also social organic type of stuff as well.
That's right.
And so what is the website?
It's spacetimedb.com.